to bed at 1 a.m.
Yes. Chapter 12 and Chapter 11 homework obviously has to be due Friday. Aw, you signed up for it.
Let's do Monday.
Just to be blunt. Alright. Turn on Monday. Won't do anything for you this semester. Linear regression. Correlation. Look at your homework sheet. You know we're right on track. So, if I asked you, somebody who's younger than 18, does their age correlate with their height? So, their age, what's it mean for the age to correlate with their height? That means there's a relationship between the two. It's exactly like algebra because it's linear regression and correlation. So, what's the slope tell you? Who remembers what a slope tells you? Rise over run.
How steep I almost said function because of calculus. How steep a line is.
How steep a line is. I love it. Where do we see it in the real world? Well, we see it all over the damn place, but where is it really in your face? If you ever go driving through the mountains, or you don't see the sign for this, but there's, I remember when I was dating somebody with kids, they would say, take the hill, Jeff. And there's a hill going down, like A Street, going towards downtown. There's that crazy hill. Well, you got a stop sign. The stop sign, the only reason it's there is just to go, all right, stop and make sure you're what you're about to do. So I would just always go there and just, they'd love it. Do it again. But if you're driving on the freeway, you'll see like runaway truck ramps. And normally you see runaway truck ramps. Right before that it said, careful, 7% grade coming up. Right, and you're like, in part of your brain goes, 7% of my grade is based on, no, shit. 7%, of course, is 7 over 100. Slope is rise over run. So that means if I'm going up a 7% grade, for every 100 feet, I write 7. Which doesn't sound like much, but considering the speed you're going, it's a decent climb. Or drop. And then just runaway truck ramp. The first time I saw that, I was like, oh. Okay. Let me see. All right. So slope tells me if I change one variable, how much does the other variable change in response to that? That's another way to say slope. As I run, and then when I run, I change x. How much do I rise or fall? That's the change in y. So how much does one variable affect another variable? That's what slope is. And that actually is what correlation is. Correlation in general, not just linear, but just any kind of correlation, means if I alter one thing, does that correspond to a change in the other thing? So I don't know if one is causing the other one. So for example, let me give you this so I got some stuff to talk about. I got some nice examples here. By the way, this is not a suggestion for an experiment to run. There's an example in here about drinking a lot of beer and then taking an early test. I don't say you should try that.
That's Friday.
So I want to get that on the camera. Yeah, I lost count. Let's see what happens here. So, Dean, if there's any student that says, yeah, the teacher told me to do it. Look at the video from this day. I should really count and stop talking. That's one more back. One more back. All right, guys, let's take a look at this. So if you did drink some beers the night before, like a 7:30 a.m. test, do you think that might affect the grade you get?
Yeah.
I had an extra one in there, didn't I? Oh, somebody else is missing. Oh, I love these people that don't stay. All right. Which one was it? Oh, it's over here. Okay. So by the way, when I applied for this job, I had to send a video of a lecture I did. I sent the video of this one, and one of my colleagues said, "Yeah, I really like the fact that you were talking about drinking beer. We were interested in getting some people on here. So if you really don't think I'm a good teacher, you're like, well, that's why I got the job. Shit. Because you mentioned beer." Turn the sun off.
The sun's still being good.
All right. So here's two kind of examples of possible results of doing something like the beer drinking thing. Now both of them have what kind of a trend in the grades? What kind of a trend? What would you say? Is it a upward trend or a downward trend?
I would say the less beers you have, the higher your grade.
All right.
Yeah.
So there's definitely a downward trend, right?
Yeah.
Now, is beer drinking the only variable that would affect your grade?
No.
No.
So anybody ever watched Mythbusters at all?
Hell yeah.
It's starting to come back now. I haven't seen any of the new ones, to be honest. I kind of miss, Walrus and Adam.
They're great.
But they really do a decent job of talking about controlling variables. If you want to analyze the effect of something, you got to control for all the other things that could affect what's going on. So which one of these would be more realistic? The first one would be more realistic. Because who is this person? What did this person do? Did they drink a lot? Relatively? They didn't drink very much. But they also didn't make a very high grade. All right? You guys with me? So they're an outlier. They're the person that, I don't care how much they drank, they don't know shit, so they're not going to do good on the test, right? What's the other outlier all about? There.
He's a genius.
Drink a lot, relatively, right? I don't have any scalars, so you can just imagine whatever. You put yourself in there. But they still made a very good grade. Maybe they can hold the liquor better, they don't get hangovers, whatever. You guys kind of with me? Which one, now that's definitely more realistic. Which one would you say is a stronger correlation?
This one, right?
Definitely this one. So the idea of how strong the correlation is seems to correspond visually to what happening? Why is this one stronger? Because?
They're closer.
Okay, I like it. We will eventually draw a line in here, but they are tighter together. They form a line better. So if I did draw, so I love it, we're going to do something called the line of best fit, and that is the name. That's not Jeff's name for it. It's a beautiful name. I love it. We got the best words. No, it's a beautiful name because it's exactly, it just best fits all the points. I call it the two-dimensional average. So again, if you ever seen those tracks of a hurricane, and I know we don't worry about hurricanes here, but I used to live in Florida, we did. And you see that cone of uncertainty. I think we talked about this earlier this semester. I can't remember. The cone of uncertainty for a hurricane. Have you guys ever seen that before?
Yeah.
Yeah, they have where a hurricane is, and then 1 day, 2 days, 3 days, 4 days, 5 days later, there's a lot of, it's like the average plus or minus a standard deviation is basically what that is. And down the center is the averaging line, the black line. It's the line of best fit of that path of that hurricane. Now, it's not linear, right? The hurricane can do all kind of weird shit. Some of them do very strange shit. Yeah, I'm going to get you. No, I'm not. No, yeah. Right? But it's the same kind of idea. It's kind of nice. This one's definitely stronger because they line up better. So if I did find a line of best fit for this one, I would trust it to make predictions more. I could say, what if I drank 2.5 beers? And then I could put it in the equation and get a grade out. Now again, here, everybody in here, including me, the way I talk about it probably, is assuming something affects something else, right? The number of beers affects your grade. But somebody could be like, I'm going to kick ass on this. I'm just going to celebrate early. So maybe the grade they made actually affected their beers. I don't know which way it goes. So in real life, we see that two things are related to each other, but we don't know if one causes the other thing to change. So for example, it is true that when teachers' salaries go up, liquor sales go up. That's a very funny thing to say, but if teacher salaries goes up, what's probably true? If teacher salaries goes up, what's probably true? Other people's salaries went up. Do you see what I'm saying? So just because two things are related doesn't mean that one causes the other. There could be a third thing that's causing both of them. Or does that make sense? You guys see what I'm saying? This test is this idea of linear correlation. It's a strong thing, but it built in is the idea that there are other variables, and it can only look at two variables at once. This variable and this variable. What's happening? There are tests that can look at more than one variable. We're not going to quite make it there. Okay. So another example, just to get something, is the amount you study versus what grade you make. So same kind of ideas. Which one is more realistic?
Second one.
Yeah, this is more realistic. You got some outliers. The person that barely cracked the book, but this could be the third time they've taken a damn class, and they haven't hit the shit that they're not really sure about, so they did really well. Or they're just one of those people that don't have to open the book at all. You know those people. And then this person, this is probably somebody who thinks they're studying but doesn't really know how to study. And that's why they got such a low grade. But both of these, of course, have an upward trend. You expect that. The amount you study should make your grade go up, but it could be the other way around. It could just be the idea that you're a good student. So you do a lot of things correctly. And this is just one of them, and that's why your grade went up. Okay, maybe. All right, so you're going to need a calculator very soon. If you don't have one, you probably want to come borrow one right now. Over here, Sure. All right. See, I'll let you guys fight over which calculator. All right, guys. So the two main things, we're going to have the calculator calculate for us are a number that represents how strong the relationship is. So the number, if I had a correlation where it was just, everything just perfectly lines up, a line goes through them perfectly. And what did you say is true about the slope of that line?
Positive.
Positive. This would be perfect positive correlation. So of course, there should also be the idea of perfect negative correlation. So this is perfect positive, meaning if one variable increases, the other one does also. And again, we don't know which one causes which one to do that, but that's the relationship. This is perfect positive. Good Lord, Jeff. You can't write and you can't see it. It's perfect positive correlation. And then perfect negative correlation makes sense. Yeah. The number we're going to calculate, it doesn't have the same scale as a standard deviation. What's the smallest that a standard deviation could be?
0.
0. Can't be negative because it's a bunch of squares and square roots. 0 to whatever. I like to think of this as a two-dimensional standard deviation. It does measure how far away the points get from the line. In fact, the other name for this line is the least squares line. It's the least squared distance. It minimizes the squared distance to all the points. You have to know that? No. Just like to throw that out there. So the letter we're going to use for this is R. Which is interesting because a lot of you guys, when you make sigma, it looks like R already anyway. So this would be R equal to 1. And this would be R equal to negative 1. Perfect positive would be 1. Perfect negative. Oh, scheisse. I didn't even know I could do that. Would be negative 1. So what do you think R equal to 0 would mean?
Straight. Horizontal.
It's a vertical line.
I love it. So there's yeah, it could either be, and why would a horizontal line or a vertical line, why would that mean no correlation?
Because there's nothing affects the other one.
Good. If the whole idea is how much does one variable change while the other one changes, these two, one's changing, the other one this shit. So it's kind of like the height of that tree and how much I jump, how high I jump. The tree doesn't care how much I jump. Shit. So the height I jump and the height of the tree are not correlated, right? One day the tree's gonna grow and I'm gonna go, I'm dreaming. Or I'm on something. Does everybody understand so far? Now, another situation where R is 0 is where the dots are just all over the place, like measles, right? There's one more that might be kind of weird. So either these are all R equals 0. This, but to be honest, that would probably have like R equal to 0.002 or something. It's almost hard to get. But that's another situation. There's no real correlation. There's no trend. And another one would be something like, get out of there. I guess I will. Like if I had points like this, is this a linear relationship? No. So that would be quadratic regression. I don't know if you guys remember quadratic. Is it x squared kind of thing? Parabola? Okay, cool. I like it. We're only going to talk about linear regression. But there does exist quadratic. What would be quadratically related? Would be temperature during the year versus energy usage. When it's really hot or really cold, we use light, but in the middle, we don't use much energy. So that would be like a parabolic correlation, quadratic. You also have natural log, logarithmic correlation. You have exponential correlation, all this kind of shit. Right? Any function you can think of is probably something that's used to correlate. Okay, so that's this symbol R. It's either called the correlation coefficient or it's called the Pearson product. And of course, my teacher for statistics was Mr. Pearson. He didn't really take credit for it. Pearson is actually one of the first people that worked on statistical methods. He's one of the first people, and the first statistics stuff was all about agriculture, trying to figure out how to get the best yield out of a set of land. That's where statistics kind of like grew up, right? And then there's an interesting story about a thought experiment or experiment about do I put the sugar in my tea first, or do I put it in after I put the tea in?
No, first.
So it's that was a little, how do I set up an experiment? So all the stuff we teach has to come from somewhere, has to be invented. So the history of statistics is really, I'm sorry, I'm trying not to geek out, and you're all like, okay, I'll stop that. So right here, we already talked about this. It goes from -1 to 1. So it kind of makes sense. It can't be more than those. It can't be further out than those. 0 means it doesn't exist. 1 means it's perfect positive. -1 means it's perfect negative. I love it. So that's the one thing, is the strength of the relationship. And the other thing is going to be the equation of the line that kind of averages where the points are. And that's the one we can actually use to make predictions, if we trust it. So the line of best fit. So let's look. I want to show you, let's see, which order do I want to do this in? Yeah, I want to show you, I think I want to do this. All right. You guys get to work on figuring out a line of best fit by hand. And then I'll show you how to do it in the calculator. I'm hoping you guys are able to figure out a nice straight edge to use. Not all of us have rulers and such, but you can figure something out. So don't do anything to this yet. Let me give everybody a copy of this. You guys can group up if you want to. And I want to show you a quick example of how to do this correctly before you start doing all kinds of weird stuff. So guys, here's how to do this sort of correctly. So let me just show you the idea of a line of best fit. Line of best fit has to average where all the points are. So let me draw a bad one, which everybody's first attempt basically will be a bad attempt. Especially if I use too many.
I have a toothbrush.
It's funny, this is good, I'm not even trying. Okay. Alright, now why is that maybe not the best? Where should it go?
The bottom corner.
What's happening? Sorry? Why is that bad?
I should start corner, right?
It's almost good, to be honest. It's not that bad. Should it be down a little bit? You guys see that?
Yeah.
Because these should be pulling it a little bit further. These are like, just like values pull the average toward them if they're heavier weighted. These are going to pull it towards them a bit. So you might want to draw once, and you're going to probably have to draw again based on where things are. So your second or third attempt is going to be the line you want to use. So let me try again. So I want this to go down a little bit from there. I stole somebody's pencil. I'm sorry, you're going to have to give another one. Oh, neat. Well, prepared. Let me see, that was a little too high, so I can maybe go just a little bit down from there. That one's better. Probably still go down a little bit more, but shoot, I think I lost your little thing there. All right, now, to make sure you understand the next step. Do you see how mine doesn't really go through, see how it doesn't really quite go through that data point? Find 2 points that your line actually goes through. See how it goes through that one, basically? That's not a data point. Let me not make it look like it's a data point. I really want you to understand. If your line goes through all these points, it doesn't really go, maybe I could argue that it goes through that one, but your line does not have to go through any of those points.
Exactly.
It doesn't. It's supposed to average where they are anyway. If it does, awesome. Use one of those points. If it doesn't, just try to estimate a couple of points it goes through, because of course to get the equation of a line, you need 2 points. And just to remind you guys, what's the formula for the slope? Don't tell me English, tell me mathish. Rise of a run. Rise rhymes with y's. y2 minus y1. X minus x1. And there's your equation. I gave it to you. All right. Do what you can. Call me over if you need some help. Everybody should get a slightly different answer.
Wait, does it have to go through the whole